In February 2026, Block eliminated 4,000 roles. That was roughly 40% of its workforce. The rationale Jack Dorsey gave to his shareholders was two words: intelligence tools. Dorsey and Sequoia's Roloff Botha soon published the blueprint behind that cut. They argued the management layer of the modern company is obsolete. Their replacement is a mini AGI, constructed from continuously updated AI world models. The system is designed to absorb the calendar load of middle management, aggregating context across departments, relaying decisions, and maintaining alignment, all at a fraction of the historical cost. This chart shows the expected trajectory of these deployments. For the first 12 months, the implementation looks like a massive operational success. Executive dashboards stay perfectly clean. Project status is synthesized instantly. But eventually, the trend line diverges from reality. Results slip, yet internal reports continue reading as a success.
By the time the damage is visible, several quarters have passed. This is a simulation of organizational intelligence, a system that appears to be working right up until the moment of a catastrophic, delayed execution failure. The entire premise of replacing managers with AI relies on a specific historical assumption: the idea that management is primarily a mechanism for routing information. You can trace this lineage directly back to Frederick Taylor and industrial-era efficiency models, where a manager's job was to pass instructions down and tally production up. Good managers do not route information, they edit it. They sit between the raw data and the executive suite, making strict editorial choices about what matters. First, this function is highly selective under deep ambiguity. A human ignores 80% of the signals on their desk because they know the difference between a routine bug report and a symptom of a dying account. Second, the editorial function is accountable. When a human makes a bad call, the loop closes. They adjust their internal model of the business and read the signals differently the next time. Third, it is intensely political. Managers step in when two departments reach a deadlock, or when a failing project is being protected by a stubborn executive. AI models automate routing perfectly, but fail at editing. When synthesizing signals, the AI homogenizes nuance, burying critical risks inside confident summaries. Vendors are selling 3 genuinely different database architectures under the single branding term of world models. Each one draws the line between information and judgment in the wrong place. This spatial field illustrates the vector database approach. The premise is that understanding emerges by embedding every document, chat, and support ticket into a semantic space, and retrieving them by similarity. When the system needs context for a decision, it grabs the nearest textual neighbors and lets a language model synthesize the result. The failure mode here is overconfident retrieval. The system returns a comprehensive-looking list and synthesizes a confident answer. What it cannot retrieve is the hallway conversation, the gut feeling a sales rep sat on, or the context that was never written down. The system cannot report what it doesn't know because it has no concept of its own blind spots. The second architecture is the structured ontology approach, favored by firms like Palantir. Here, the business is formalized into a strict, predefined map of objects, rules, and relationships. You explicitly code what a customer is, what a partner is, and how they interact. The failure mode is premature formalization. When a novel edge case emerges, like an account acting as both customer and competitor, the rigid schema breaks. The ontology fossilizes the business in its present state. The third architecture is the signal-driven approach, which relies purely on raw transaction histories and telemetry data. The failure mode here is signal monoculture. The model converges aggressively on whatever metrics are easiest to measure. Qualitative realities like trust, internal morale, and friction disappear completely from the system's worldview. Every single one of these architectures fails for the exact same reason. They force the machine to make internal judgment calls about what data matters. Before selecting any database architecture, you have to build an explicit structural constraint into the system. This is the boundary layer. It sits entirely separate from the data below it. The structural rule is absolute. The AI is strictly permitted to report information up to this line. The human sitting above the line must execute the final judgment. User interface disclaimers or numeric confidence scores are insufficient. The system cannot be allowed to render a decision disguised as a data point. When you deploy this, middle managers will push back. They will complain the system is making assumptions it shouldn't. That friction is the signal you need to listen to most. Without this hard boundary drawn first, the vendor-supplied architecture bleeds upward, slowly taking over the editorial function while no one is watching. To keep that boundary layer intact, the architecture requires a second mechanical step: outcome encoding. The vast majority of enterprise deployments fail here. Companies spend millions shipping the retrieval and synthesis layers, but completely fail to wire the downstream results back into the system. There must be a mechanical connection between the human's final execution and a measurable downstream outcome. If an AI surfaces a priority list and the human acts, but the model never learns if it worked, the system operates in an open loop. It degrades silently. Closing the loop lets the model grade its own paper, confirming which signals correlate with success. An open-loop model rots. A closed-loop system earns its complexity and compounds value over time. This matrix maps specific company profiles to the structural bets they need to make. If you run a high-volume transactional business with rich telemetry data, like a fintech or a marketplace, the signal-driven architecture is the correct base. If you operate in defense, healthcare, or heavily regulated financial services, the complex relationships require the structured ontology approach. For knowledge work companies, consulting firms, and B2B agencies, the stack requires a hybrid. You start with vector retrieval, cap it with a lightweight ontology to define key entities, and seal it firmly beneath the human boundary line. But none of these stacks matter if they are fed distorted pipeline data. You must cut incentive-corrupted metrics and prioritize clean, honest signal capture. Selecting the right technical architecture only gives you the baseline capacity to build the human boundary correctly. It is not the solution itself. The ultimate test of a world model over a 2-year timeline is defined by what the system is actively accumulating. Poor implementations accumulate summaries. They ingest status reports, executive briefings, and slide decks. Feeding entirely on summaries, the system generates its own internal logic. It develops organizational dementia, highly confident, yet entirely detached from reality. Systems that compound value accumulate contact with reality. They track raw shipped code, completed transactions, and verified customer outcomes. Mid-market CEOs are going to face aggressive vendor pitches for these tools over the next 6 quarters. The first-order economics will be impossible to ignore. When your best managers push back against the deployment, recognize that resistance is a feature of a healthy transition. They are protecting the editorial function the machine cannot replicate. Sustainable deployment requires the courage to enforce a structural boundary between algorithmic information and human judgment. Success depends on protecting the editorial layer from the very architecture meant to support it.